Once again, welcome to you all. This is Srinivas going to explain another important topic from control system subject, that is to find out the transfer function of a given control system. Finding out transfer function of a given control system. Okay, finding of transfer function of a given control system. So in order to find out the transfer function, or this can also be called as the closed loop transfer function, or otherwise the overall transfer function, this can also called as this transfer function. Okay, this transfer function can also called as closed loop transfer function. Closed loop transfer function, that is CLTF, or the overall transfer function. Okay, the overall transfer function of a given control system. Okay, so sometimes they may ask you to find out closed loop transfer function, or otherwise it is also called as overall transfer function. Clear? Now there are basically two methods are there to find out the closed loop transfer function. There are two methods. What are the methods? What are the methods we have to find out the closed loop transfer function, or otherwise the overall transfer function? Okay, we have basically two important methods to find out this transfer function. Simply I can write TF. Instead of writing all that, I can write TF. Okay, so we have two important methods to find out this transfer function. What are the function we are now explaining now, that we have two types of transfer function, two types of methods are there. The first method is this is block diagram reduction method. Block diagram reduction. reduction. Block diagram reduction method. This is the first method. Okay, block diagram reduction method. And secondly, this is called signal flow graph method. Signal flow graph, SGF, otherwise signal flow graph method. Okay, this is the another important method. The first method is block diagram reduction method, and secondly this is called signal flow graph method. These are the two important methods can be used to find out the transfer function of a given problem, simply given problem. Let us look about block diagram reduction method. Block diagram reduction method, the first one. Now I will explain about the first one, block diagram reduction method. Let us see what is this block diagram reduction method. What is a block diagram reduction method? In block diagram reduction method, as the name itself implies, that in the given problem you will have number of blocks, as we have seen, either in open loop or otherwise in closed loop. So we are representing the gain as a one block, as well as the feedback element is another block. These are what the blocks means. Likewise, these are called the blocks. So in any given problem there could be many blocks. Okay, for our understanding, so I am explaining you that only one gain element we are taking and one feedback element we are considering. With one gain and one feedback element, we are deriving the expression for closed loop transfer function with positive feedback as well as the negative feedback. But in the problem, it could be any number of gains, not necessarily one. It could be G1, G2, G3, G4, or any number of gains. Similarly, in feedback element also there could be any blocks. Therefore, the blocks will be more if the number of blocks given. How to find out? So for that, if the number of blocks given then by reducing those more number of blocks into smaller one, we have to find out the transfer function. That is what the meaning of this method, block diagram reduction. The name itself implies that block diagram reduction, we have to reduce the number of blocks. And then we have to find out the transfer function, that is the ratio of C of S by R of S. We have to find out. So for that we have certain rules. There are certain rules to be applied in order to find out the transfer function. Okay.